This reader comes from Matter in Motion, Unit 1, Student Reader. You will begin on page 33. You may follow along here on the screen or follow along in your book. Patterns on Earth, Gazing into Space. Long before the Hubble Space Telescope was launched into space, people used to watch the sky. They noticed the patterns in how the sun, stars, planets, and moon moved across the sky over a day, a month, and a year. From Earth, it appears as though our planet stays still, while the sun, moon, and stars travel around it. The sun appears to rise in the east and set in the west. The moon seems to travel across the night sky, and the stars appear in different places in the night sky depending on the time of year. Scientists now know that the Earth is in constant motion. Earth and the other planets orbit the sun, while the moon orbits the Earth. At the same time, Earth is also rotating. This means it spins like a top. Day and night. Earth rotates on an imaginary line that goes from the North Pole to the South Pole. This imaginary line is called an axis. Earth rotates very quickly. Earth completely rotates around its axis about once every 23 hours and 56 minutes, 1 Earth day. The reason we don't feel like we're speeding through air is similar to how it can feel in an airplane, like the plane isn't moving. Gravity holds us all onto the planet, and so we rotate with it. As Earth rotates, part of the planet gets light, and then dark. The sun always shines, but its light only hits one half of Earth at a time. This is why we have day and night. The patterns in how the sun, stars, planets, and move across the sky are caused by Earth's movement. All of these bodies appear to rise in the east and set in the west over one day because of Earth's rotation. Telling time with shadows. During the day, the sun appears to move across the sky. At dawn, the sun appears close to the ground in the east. As hours pass, it moves upward. By noon, the sun appears directly overhead. In the evening, the sun appears close to the ground again, this time in the west. At night, the sun appears to disappear. Long ago, people noticed that as the sun rises in the east, it casts shadows that change throughout a day. Shadows are dark shapes created when an object blocks light. The length and direction of the shadow depend on how low or high the sun is in the sky. When the sun shines down from directly above you, your head is the only part of your body blocking the sunlight. As a result, there is very little shadow. In the middle of the day, around lunchtime, your shadow will become very small. It might even disappear. In contrast, your shadow will be the largest when the sun is near the horizon. This is because your body blocks more light. Changing seasons. Shadows also change throughout the year. Shadows are much longer during the winter months than during the summer months. Shadows change throughout the year because the sun appears in the sky at different heights depending on the season. A season is a period of time characterized by specific weather patterns and by the length of day and night. In the summer, the sun appears high in the sky. In the winter, the sun appears much lower in the sky. We now know that the sun appears to be in different locations throughout the year because of Earth's position in the solar system relative to the sun. As Earth moves around the sun, it is tilted 23 5/10 degrees on its axis. Because of Earth's tilt, the northern and southern hemisphere each receive different amounts of sunlight throughout the year. For half of the year, the northern hemisphere is tilted toward the sun. The sun appears to be high in the sky, so the sun's rays shine more directly onto Earth, at a higher angle. When this happens, shadows are smaller, and temperatures are warmer. At the same time that it is summer in the northern hemisphere, it is winter in the southern hemisphere. This is because the southern hemisphere is tilted away from the sun. The sun is lower in the sky, causing the sun's rays to hit Earth at a lower angle. This causes the sun's rays to spread out over more space, causing longer shadows. It also makes temperatures cooler. For the other half of the year, the northern hemisphere is tilted away from the sun, and the southern hemisphere is tilted toward the sun. Now it is winter in the north and summer in the south. Changing constellations. The sun is not the only object that appears to move in the sky. Long before we had calendars and clocks, the movement of the stars was another important sign of the changing seasons. Each night, a few stars appear in the east that weren't there the night before, because the Earth has moved slightly in its orbit. People named patterns in stars based on these famous animals, objects, or people. These patterns are called constellations. Perhaps the best known constellation is Ursa Major, which looks like a big bear. The tail and back of the bear are also the 7 bright stars that make up the Big Dipper. Other constellations include the Summer Triangle and Orion. When the Summer Triangle is visible, spring and summer are near. When the constellation Orion is fully visible, the cold of winter is coming. Unlike constellations such as the Summer Triangle and Orion, some stars can be seen in the sky all year. For example, Polaris, or the North Star, is an example of a star that doesn't appear to move from the northern hemisphere because it lies almost exactly above Earth's northern axis. Why does the moon change? People have long used the movement of the moon to mark the passage of time. Within a month, the part of the moon that we see from Earth changes from a full white disk in the sky to a small sliver, and then back to a full white disk. These changes are called phases. They occur because of the changing positions of the moon, Earth, and the sun as the moon orbits Earth. It takes the moon 29 5/10 days to completely orbit Earth once, about equal to 1 month on Earth. The moon doesn't emit its own light. Instead, we see the moon because the sun shines on it, lighting it up for us. Exactly half of the moon is always in sunlight, in the same way that half of the Earth is always in sunlight. The same side of the moon always faces Earth, but the part of the moon that we see depends on where the moon is in its orbit around Earth. Sometimes we see parts of both the sunlit portion and the shadowed portion.